All right, this is 7B notes. We're going to be looking at the definition of logarithms today. So definition of logarithms with base b. Let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted by log base b of y and is defined as the following. Log base b of y is equal to x if and only if b to the x equals y. So this is an example of log notation, and here we have exponential notation. We're going to be changing back and forth between the two notations today. Now logarithms allow you to solve for exponents. So we're going to be solving equations eventually with logarithms and exponentials. Logarithm functions and exponential functions are inverses of each other. The most important thing you have to remember is a log is an exponent. A log is an exponent. So repeat this over and over and over again. Like I said, a log is another way of writing an exponent. All right, some special names you need to know. A common logarithm. You're going to see this. Log x. It means log base 10 of x. Common log means the base is 10. The 10 is assumed to be there. All right. Natural log, ln of x, all right, has a base of e that's implied. You don't have to write it. All right, some facts you need to know. Log base b of 1 is always going to equal to 0 because if we rewrite the exponential form, b to the 0 is equal to 1. Anything raised to the 0 power is equal to 1. And then log base b of b is equal to 1. So if we rewrite this, b to the first power is equal to b. Anything raised to the first power is itself again. So there's two facts that you need to remember because you're going to be seeing those a lot. All right, so let's just practice. What we're going to do first, here's a little history of logs. You can pause the video and read it. But just like I said, where logs came from. So basically, logs were designed or invented so that you'd have a way of solving these equations that we're going to be seeing. Like I said, pause the video and you can read I'm not going to read it to you. You can read the history of it. All right, so what we're going to do first is we're going to change back and forth to different forms because that's what you need to be really good with this. We can simplify a lot of expressions, solve a lot of equations by being able to switch back and forth between logarithmic and exponential form. So we got log base 2 of 32 is equal to 5. The 2 is the base, okay? So, and the 5 is going to be our exponent. So in exponential form, 2 to the 5th power equals 32. And it makes a true statement. All right, let's try the second one. Our base. Locate your base first. So 7 exponents, what's by itself? 0 is equal to 1. All right, why don't you try the next one? I'll give you a little bit of a head start. All right, the answer should be 13 to the first power equals 13. All right, try the next one. All right, answer is 1/2 to the negative 1 is equal to 2. Remember, a negative exponent tells us take the reciprocal. All right, so that's going from logarithmic form to exponential form. Let's go the other way now. So take a moment and add these to your notes. They aren't on your original notes, so please add these questions. We're going to go from this time from exponential form to logarithmic form. And a way to remember this, going from exponential to log, is BAP. Base, answer, power. Base, answer, power. BAP. All right, so let's try these. 3 squared equals 9. So change it into logarithmic form. It's going to be log base 3 of 9 is equal to 2. Remember that the exponent is always by itself. All right, let's try the next one. So we're going to have log base 10 of 100 is equal to 2. And since this is common log, we don't have to write the base of 10. You're not going to see the base 10 written. It's implied. All right, you try the next one. Take a moment and try the next one. All right, answer is log base 16 of 4 is equal to 1/2. Remember, rational exponent means, so 1/2 is the same thing as square root. So like I said, we have a true statement. Okay, so like I said, we're gonna begin using this, going back and forth between the two forms to simplify and do some different expressions here. So look at the next type of question we're gonna have. Let's evaluate the logs. Okay. All right. Something you have to remember here is that we must have the same basis. Must have same basis. And I'll explain how we're going to use this here in a moment. All right, so we're going to simplify this. So that means we're going to change it. I'm going to change this to exponential form to simplify this. So I'm going to equal to my unknown. I want to find out what this is equal to. All right, so let's change from log to exponential. Whenever in doubt, change the form. Now, a lot of time the answer just kind of falls out at you. All right, so change it to exponential form. So my base is 3, so 3 to the x is equal to 81. Now, in order to be able to do this problem, I need both of these to have a base of 3. All right, because that's my lowest number here. So we got to think about, how can I rewrite 81 with a base of 3? Well, 81 is 3 to the 4th power. So that means my unknown, my x, is equal to 4. Okay, let's look at B. All right, so here again, I'm going to equal to something. All right, change the form. I'm also going to change that 0.25 to 1/4 when I change the form here. So I'm going to have base, so 4 to the x is equal to 1/4. Now, I need to rewrite both of these so they have a base of 4. So I'm going to go 4 to the x power is equal to, well, I can make this a negative exponent, -1, and that makes me both have a base of 4. So that means this expression simplifies to -1. Like I said, changing the form a lot of times will, like I said, the answer, you can just see the answer. The answer becomes very obvious. When in doubt, change the form. All right, why don't you try the next one? Pause the video if you need to, give yourself some more time. All right, let's work through it. So equal to x. So I've got 1/4 to the x power is equal to 256. Okay, so I want these to have the same basis. I don't like that fraction, so I'm going to get rid of the fraction by I have the base of 4 to the -1x is equal to, now I want to, so how can I rewrite 256 with a base of 4? Well, 4 to the 4th power is 256. So that means -1x is equal to 4, so that means my x has to be -4. So this expression simplifies to -4. All right, try the next one. So I want this to equal to x. So I got 49 to the x power is equal to 7. All right, I need to have the same base here. So that means I'm going to rewrite this with a base of 7. I always want to go to the smaller number, right? When I rewrite a base, it has to be the smaller number. So 49 can be rewritten as 7 to the squared, which times my x. So I've got 7 to the 2x is equal to 7 to the 1st. Set my exponents equal to each other. So that means this expression simplifies to 1/2. So when in doubt, change the form. All right, moving on. Let's look at inverse properties. So we said that logs and exponentials, by graphing, we saw that they were inverses of each other. So if we let g of x equal log base b of x, we say it's the inverse of the exponential function f of x equals b to the x, if and only if we take the compositions, so we put one inside of the other, and they both simplify to x. This is the same properties of inverses that we talked about in a previous unit. All right. So here again, if I change the forms, all right, we're going to hopefully our answers. You're going to see what your answer is. All right. So let's look at log base b of b to the a. So if this is going to equal to something. All right. We got something. I don't want to use an x here, but it's like that's some simplified version. So if I change, so this is in log form. Let's change it to exponential. So that means b to my unknown exponent is equal to my answer, which is b to the a. So that means this is going to simplify to just a. So my unknown value that simplifies to is a. All right, let's go the other way. Here again, I've got some unknown value that this is going to simplify to. All right, this is an exponential form, so I want to change it to log. So I've got log base b of my answer is equal to my exponent, which is all of this. All right, so what's my unknown? Well, my unknown has to be a again. So it's simplifying to a. All right, let's use our inverse property to simplify these expressions. So here I'm going to rewrite this. So I've got 10, this is exponential form. So 10 to the log base 10 of 6.7. That's going to equal to something. All right, we're going to simplify this. And like I said, here you can use an x if you want to. Like I said, it's going to, our question mark is just going to equal something. The reason I turn it into equation, that way I can change the form. All right, so now this is an exponential form, so I'm going to rewrite it in log form. All right, so I've got log base 10 of my answer is equal to my exponent, log base 10 of 6.7. All right, so compare the two. What does this simplify to? Well, it has to simplify to 6.7. Because that's what my unknown, to make the sides equal to each other, that has to be my unknown, my box has to be 6.7. All right, let's try another one. All right, this is in log form. That means I'm going to change it to exponential. So I've got 2 to some unknown exponent is equal to my 16 to the x power. All right, so now here again, I have to have the same base. Must have the same basis. So how can I rewrite 16 with a base of 2? Well, 2 to the 4th power, and I already have that x. So that means this expression simplifies to 4x. So that my answer here is 4x. And we'll practice some. Like I said, when you get really good at changing the forms, that's what makes this so much easier. Being able to change easily back between exponential and logarithmic forms. All right, let's look at some inverses of functions. All right, first of all, let's make a few changes on your notes. So B, change that to a +4, and add C, y equals 6 to the x. All right, just like we did inverses in a previous unit, we're going to switch the x and the y, and we're going to solve for y. Switch the x and the y and solve for y. All right, so here, let's set this up to find the inverse. X is equal to log base 3/2 of y. Now, to solve for y here, we're going to change the form. So to solve for y, change the form. Change to exponential. Because it's in logarithmic form, we're going to change it to exponential. So that means that the base, 3/2 to the x power, is equal to y. All right, and there's our function. There's our inverse. So y is equal to 3/2 to the x power. So to solve logs or solve exponential, change the form. All right, let's try B. Switch x and y first. So x is equal to the natural log of y plus 4. I changed the problem, remember? All right, remember our implied base for our natural log is e. All right, so let's change the form. We're going to change it to exponential. So it's going to be e to the x is equal to y plus 4. All right, solve for y. So we're going to subtract 4. So our new equation is y is equal to the e to the x minus 4. To change the form. All right, let's go the other way. Now this one is an exponential form. We want to find the inverse. That's why I added this problem. All right, so same thing again, change the x and the y. So x is equal to 6 to the y power. All right, this is in exponential. That means we want to change it to log. To solve for y, change the form. So this is going to be log base 6 of x is equal to y. So y is equal to log base 6 of x. My BAP, base, answer, power. All right, here are some for you to try. All right, these are on your notes, so write these down. Pause the video if you need to. All right, so take a moment, work through each one of these, and we go check your answers. So like I said, pause the video if you're not ready. All right, so the answer to number 1 is 7x. All right, here again, what I would do with this is go 10 log 10 of 7x common log is equal to some unknown. All right, this is exponential. That means I'm going to change it to logarithmic. So I'm going to go log base 10 of my answer is equal to my exponent. So that means my unknown must be 7x. So that means this simplifies to 7x. All right, try the next one. Like I said, here again, if you need time, pause the video. All right, answer is 3x. How did you do? All right, here's the work. Some unknown, here again. All right, here again, this is log, so I'm going to change it to exponential. Hope you're seeing a pattern here. Change the form. When in doubt, change the form. So 3 to some unknown is equal to 27 to the x power. All right, same basis. We always got to have same basis. So how can I rewrite 27 with a base of 3? So 3 to some unknown is equal to 3 to the third power times that x I already had. So that means my unknown has to be 3x. So it simplifies to 3x. All right, try the next one. Write the inverse. Answer is y is equal to log base 7 of 2x. Here again, let me work it out for you. All right, switch the x and the y. X is equal to 7 to the 2y. All right, this is exponential, so that means I want to change it to logarithmic. So log base 7 of x is equal to 2y. That answer is not right, is it? We need to divide by 2. So my answer should be log base 7 of x over 2. So that answer is wrong. There's your correct answer. Okay? All right, let's see about the next one. That one should be over, that answer's wrong. So y equals log base 7 x over 2. Okay, all right, let's try the next. Here's the answer to the next one. Y equals e to the x minus 6. All right, try that. Let's see. How do we work that one? Switch the x and the y. X is equal to natural log y plus 6. All right, remember our implied base is e. All right, change the form. So we're going to have e to the x is equal to y plus 6. Subtract 6, e to the x minus 6. All right, couple more to practice. Try these evaluating ones. Pause the video. All right, here are the answers. 3, -5, -3, and 3 halves. So see how you did. If you have any questions, please ask them in class.